Hi, in this video we are going to see about a Python IEEE project which is entitled as SMS Spam Detection using Machine Learning, which is an enhancement of IEEE base paper title Investigating Evasive Techniques in SMS Spam Filtering, a comparative analysis of machine learning model, which is an IEEE 2024 journal paper. Before seeing the execution of the project, let me brief about this project. So we all know that SMS was used in the mobile phones, even though it was introduced long ago, which is around 1992. Till date we use SMS for various purposes like receiving the OTP or for verification kinds of thing. We are using SMS till now. And we all know that after the increased in usage of internet services, we started using WhatsApp, Telegram kinds of thing, but still we use this SMS for some limited purposes like for receiving the OTPs and verification kinds of thing. Now the problem here is there are various tools are available now for sending bulk SMS to various people. So the scammers or marketers will be targeting with a link in it and they will be sending it in a bulk manner. If someone clicks that link, they will be affected. If it is a spam SMS, then the people will be a victim, whoever clicks that link. So every year lot of SMS scammers do this and reporting that many people have lost their money, data, and etc, many kinds of things. So SMS spam detection plays a main role. So here we wanted to make a SMS spam detection system with large data. So we are going to use a large data set for identifying this. So in this base paper, the authors have made a comparative analysis. So they have used various different models. So we cannot use all the things that is mentioned in the base paper. So we are not going to use all the things that is mentioned in the base paper. So now in the conclusion, you can see that they have concluded that only a few deep learning models have performed well in classifying the spam messages with precision score of about 90 and 80%. So with this value we are going to enhance the system. So now let us see about our proposed system from the base paper. So now we are going to implement using two different models. One is support vector classifier and another one is CatBoost. So CatBoost is based on a gradient boosting. So here first model support vector classifier achieved train score of 99.2% and test score of 98.30%, which is more than the existing system, that is the base paper. And the other model that we have done, CatBoost, also achieved the best train score of 97.76% and test score of 97.19%, which is still best from the existing base paper, but from this to support vector classifier performed well. So now with this information we'll see about the data set part. So in the data set, as mentioned, the data set contains a large data set record. So it is around the data set records are around 67,010 dataset records are available, and there are two features available, SMS and the label. So this is the data set that we are going to train up the system. Now coming to the abstract part, here you can see our proposed project title and the base paper title. This is the IEEE base paper abstract, and here in our proposed abstract you can see we are implemented using Python, and the front end part contain HTML, CSS, JavaScript with web framework, Flask framework. We have implemented it, and as mentioned we'll be using the support vector classifier and the CatBoost classifier, and those accuracy values have been mentioned in the abstract part. And here we have mentioned about the data set part, which contains around 67,010 instances with two attributes in it. So the two classes are spam or ham. So spam or the non-spam. So that is been two classes available in it. So those all details have been summarized in the abstract part. And coming to the existing system, so we are going to take the base paper as a existing system. So in the base paper, as mentioned, they are used various deep learning models. So those details have been mentioned here in the existing system, and here you can see the list of disadvantages of the existing system. And coming to the proposed system, as mentioned, the proposed system with the technology, the models, the accuracy values, so everything is being summarized here. And coming to the advantages of proposed system, you can see the list of advantages of proposed system with the high accuracy, robust performance, efficient handling of text data, reduced overfitting, user-friendly interface, scalability, comprehensive data set, versatility in model selection, ease of maintenance, real-time processing capability. So these are the list of advantages of our proposed system. Here you can see the system architecture, which contains the input as SMS text data set, and pre-processing feature selection is made, and we can select any of the model like support vector classifier or CatBoost, and the predicted result will be spam or ham. And finally we'll show the performance analysis and graph part. So this is the system requirements, hardware requirements, and software requirements. This can be executed in Windows 10 or 11. Coding language uses Python 3.10.9. Web framework is Flask, and front-end part contain HTML, CSS, and JavaScript. And this is the reference of the IEEE base paper. Now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python libraries installed in the system. So now inside the source code location, we have the SMS spam folder. Inside that we have this app.py file. So now in the address bar, I'll just type cmd and click enter. So automatically the command prompt window open with the exact location where we have typed it. And now type Python app.py and click enter, and kindly wait for a few seconds. Now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, just paste it and click enter. So now you can see the home screen or welcome screen of the project with the project title SMS Spam Detection using machine learning. So now just click this login menu, it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and admin. Both are admin and then click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload part where you need to upload the dataset part. So just select this choose file. Inside the go to the project source code location. Inside that we have given the upload.csv file. Just select this upload.csv file and then click the upload button. As the dataset records are more, it takes some time, so kindly wait. So now after some time we can just preview the dataset that is uploaded. So here you can see this detail. So as mentioned, there are more dataset records. It took some time for me loading into it. My system has 8 GB of RAM only, so it took some time for it. So now after this you can just scroll down to the end of the page and you can find this click to train or test button. Just click it and kindly wait for a few seconds. So now you can see the training finish message and click OK. So now it will be navigated to the important part, that is the prediction part. So here you can enter the SMS and check it out. And another one you can select the model. So as mentioned, we'll be using two models. So you can select SVM or the CatBoost. So whichever model you are selecting, according to that model the prediction result will be shown. So now let me show you with few test cases. So I'll take some test cases and show you with both the cases of the spam and ham. So first let me copy your data and paste it. So the data SMS text that I pasted is your bank account have been suspended, click this link. So this is the generally spam that will get it, and so I have pasted that text, and now I have selected the model as SVM and then click the predict button. So now you can see the prediction result. So what is the message that we have typed, though that message will be shown here, and here you can see the predicted result. So predicted result is spam. The model that we have selected is SVM. So it will be the result page shows the message, what is the prediction result and what is the model that you have selected. Everything will be displayed in this prediction page. So now if you wanted to check with other case, just click this prediction menu again, so that it will be navigated to the prediction menu. So now what I'm going to do, I'll just paste the same text again and just select the model as CatBoost and then click the predict button. So now you can see the prediction result. So it gives the same result, that is it is a spam SMS, and the model that is selected is CatBoost. You can see the message that we have. So now let me go to the prediction menu again. So I'll just show you with some non-spam message. I'll just select here and then let me select the model as SVM and then click predict button. So now you can see the message that I have selected is, so you know, where's the Photoshop in Clementi. So this is the text message that I have selected. You can see the prediction result is ham. So ham means it is not a spam, and then the model selected is SVM is being shown here. And now let me go to the prediction menu again. Now this time I'll just select the same message and change the model to CatBoost and then click the predict button. So now you can see it is also predicting the same as ham and the model selected as CatBoost. So now let me go to the prediction menu. So in this way you can check with all the test cases. Now I'll just go with the training data set. So what the data set that we have used, and from that I will just give a random result. So we have a large data set record. So I'll just scroll down randomly. I'll just select something around randomly and let me select this. So this is the message that we have selected, and then they'll select the model as SVM and then click predict. So now you can see the prediction result is spam and the model is SVM. So let me go to the prediction menu again. So now similarly in the training data I'll just select some other for the non-spam category. I'll just paste it and then click predict. So now you can see the prediction result is ham, which is a non-spam. So in this way you can check with the all other cases that is available in the test or the train folder. So for the scenario I have shown you with a few cases with both the classes or with which has the spam and ham with the both the models of SVM and the CatBoost. So now let me move to the performance analysis part. So just click this performance analysis menu. It will be navigated to the performance analysis part. So here the performance analysis parameters are recall precision F1 score that is available for both the model of support vector classifier and the CatBoost model. So first let us see about the support vector classifier. So here we have the recall precision F1 score for both the cases of ham and spam. And now you can see the another performance analysis parameter, that is confusion matrix for the true and predicted label for the support vector classifier. And coming to the next model performance analysis parameter, CatBoost parameter, which has the recall precision and F1 score values for both the classes of ham and spam. And here's the confusion matrix for this CatBoost classifier, which contains a true and predicted label of it. And finally let us move to the chart part. So this chart part contains two charts, that is accuracy chart and the static data visualization chart. So kindly note that this is a static chart only. As mentioned earlier, we are not using any database in the project, so we cannot show any variations in it. So this is a static chart, which from this, the first chart shows the accuracy chart, accuracy score of the support vector classifier and the CatBoost. As mentioned, we have the support vector classifier as the highest accuracy, which is around 98.36, and CatBoost has 97.1%. So that has been depicted in the accuracy chart. And in the static data visualization chart, we have the ham and spam percentage, which is used in the dataset part. So the dataset part contains 60% of ham messages and 40% of the spam messages. So that is being represented pictorially in this data visualization chart. And now let me log out. And this is all about the project SMS Spam Detection using machine learning. And thank you for watching.